So representation of a list can be done using any of these representation, any of these methods. Then let us look at operations on a list. What are the operations that we perform on a list? Now for the operations, I will write few operations here. Then again, I will explain all of them. So the operations that I may be performing on the list is, in this set of elements or the list of elements, I can add more elements. So the operations that I can perform is add an element, that is X, or I may want to remove some element from this one. So remove an element, or I want to search for any particular element. So let us say it is search. I want to search for any element, key element, like this, so on, so on. I'll be discussing all the operations afterwards. Now let me finish abstract data type here. See, this list is an abstract data type. It is having the representation of data and the operations on the data. So when you have two things, data representations and operations on the data together, it becomes a data type. It becomes a data type. Now this I can put together and I can define a class in C++ or in any other object-oriented programming language. Then the question is how you'll be storing this list of elements, either array or linked list. Whatever is used, this is going to work perfectly. I'll be performing these set of operations only. Now how the representation is done, I need not bother about it. I need not bother about. When a class is written, I can just create the object of a class and I can use it. So how internally the things are working, I need not worry. That's what it's abstract. So the concept of abstract data type, define the data and the operations on data together and let it be used as data type by hiding all the internal details. So this concept of abstract data type is very common in C++. So I can say that when you write any class in C++, which has the data representation and operations together, it defines an abstract data type. So in our subject data structure, we are going to learn about various data structures like array, linked list, stack, queues, graphs, trees, hash table. All these things we will try to represent them as abstract data type. So I'll be showing you the code for C language as well as I'll be showing you the code for C++. So I'll be showing you how ADT is implemented. We will be defining all these data structures as abstract data types through C++. So while learning other topics, I'll show you how it is working as ADT. Now next, let us look at these operations on a list. I'll just explain you few operations on a list. What is the meaning of these operations? Now I'll explain you the operations on a list. Let us look at the operations one by one. See, first operation, I will call it as add. Add some element. Adding an element, this makes the meaning that I want to add something to the end of a list. Like suppose I want to add 15. So 15 should be added here at an index 7. So add means adding an element to the end of a list. So this is the meaning that we can take. And even this add can also be called as append. Append an element. I'll write in short for an element. So this also means that adding some element at the end of a list. Now next operation, add an element at a given index. So adding an element at a given index. For example, I want to add 20 at index 6. So here I want to insert 20. So it means already the element 12 is there. Then I should shift the element and make a free space for 20. So it means I should move 15 to the next place on index 8 and I should bring 12 here. Then I should insert 20 here. So if you want to insert any element at a given index, then you have to shift the elements. So that's what adding an element at a given index. Adding an element at a given index. This can also be called as insert. Insert at a given index. I'll write in short, that is INDX for index, this element. adding at a given index, we can also call it as insert. Then next, remove. Removing an element. So which element you want to remove, you must give an index. Suppose I want to remove 20, the one I have inserted just now. So it means this 20 should be removed. When you remove 20, that place will be vacant in a list. So we have to shift the rest of the elements. So 12 should come here and 15 should come here. So I'll be having total 8 elements indexed from 0 to 7. So that's all, removing one element. So rest of the elements are still the part of a list. Removing from given index. Then next operation is set at index a new element. This means changing an element at a given index. Suppose I want to change an element at index 3 to 25. So change this 4 to value 25. So set can also be called as replace, that is replacing an element. Replace at a given index a new element, ELE. Then get index. This is just I want to know the element at a given index. Like I want to know what is there at index 5. Index 5, the value is 10. So knowing an element from a given index. Then search for any given key. So searching an element in a list. Like I want to search for an element 9. So yes, it is found here at index 2. The result of search is we get the index. We know the element 9. We want to search for it. So we should know where it is in a list. So it's at index 2. So searching for an element to find its index if it is present in the list. This search is also called as contains key. So we want to know whether this key element is there in the list or not, or the list contains that element or not. Next, you may want to sort the list. So you want to arrange all these elements in some order. That is, you want to make it as a sorted list. So these are the few operations on a list I have shown you. There are other operations also you can perform. That is, you can reverse a list, and when there are more than one list, you can combine them, or you can merge them, or you can split a list. So a lot of other operations you can perform on a list. So as a part of topic, that is ADT, I have taken an example of a list and I have shown you how it is represented and what are the operations. So I have explained you what these operations means. So that's all about ADT. So let us move on to the next topic.